Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutiwa Sos Ugobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 2, still on vectors in 2D. It says a pulley system is used to keep a crate of mass mkg stationary, right? It's used to keep mkg stationary as shown on the diagram below. Then 2.1 says define the term resultant vector. So we say a resultant vector is a single vector that has the same effect as two or more other vectors acting together, right? And that's how you're expected to define that. Then 2.2 says calculate the vertical and horizontal components of T2, and that's for 4 marks, right? Then to calculate, let's start with the horizontal component. So let's say horizontal comp. So we know horizontal component is fx is equals to f cos theta. But then in our case, we are calculating for T2. So we can edit the formula here to say T2. So remember, you can edit the formula. And then now it becomes T2x. So the horizontal component of T2 is what? T2 cos theta, right? Now, what is the value of T2? That's 245. And then that's cos. The angle that we have here, remember, every time we are calculating the horizontal and vertical component, we must use the angle that is between the x-axis and the force, right? It's different from when you are drawing, right? When we are calculating, we must use the angle that's between the x-axis and the force. So that's 30 degrees, right? Then punching that into your calculator, you have T2 of x is equals to 212.18 newtons, right? And then let's calculate the vertical component. So don't be lost. We are still on 2.2.1. And then now we are calculating the vertical comp. So you'd get the mark for that. Then that's T2 of y. This becomes T2 sine theta. Then again, what's the value for T2? 245. And then we have sine 30 degrees. Now, if you punch all that into your calculator, you now have 122.5 newtons, right? And then again, you get 2 marks. So in total, you have 4 marks, right? So, okay, now that you have calculated the vertical and horizontal components of T2, they now say they want the magnitude of T1, right? Now, for this one here, this is what you can do, right? You can choose to resolve this, right? If you are choosing to resolve, that means your T2 resolved to what? To T2y, because it's a vertical component. Remember, it goes up. So all you have to do is this. This becomes your T2y, and then this here becomes your T2x. So this is a T2x, and then we can see that our T1 is acting horizontally like that. Remember, don't mind this, right? This is not the force. The force is being exerted horizontally like this. So this is just the rope that is being pulled, but the force is here. So do not be confused and do not try to draw this like that. So the force is horizontally here. Then down here, we have the gravitational force, Fg. And then here, this is T1. At this point, if we say this is stationary, which suggests that the system is at equilibrium, then we know what this means. It means that the forces on the left are equal to the forces on the right. The forces upward are equal to the forces downward. So it simply means that T1 is equals to T2x and T2y is equals to Fg, right? Now we can use that in 2.2.2 to calculate. So we want the value or the magnitude of T1. So we say T1 is equals to T2x, which means whatever that we found as the horizontal component of T2 is the same value for T1. So when we go back to our question, what did we find as T2x? We found 212.18 newtons. So that's all you needed to do to indicate that you understand that T1 is equal to T2x, it's a mark, and then to show us the value, it's another mark. So that's how you could have got that 2 marks. Right. Now, 2.2.3, they want the mass m of the crate. But then we know we get the mass from only one formula, from the formula that goes W is equals to m times G. That means, in other words, in order to get the mass, we need to still figure out what is the weight, or the what, or the gravitational force. So the weight here, or the gravitational force, is this one. So how do we calculate that? Remember, we just concluded or deduced that the left forces are equal to right forces and upward forces equal to downward forces. That means here we can clearly state that our gravitational force is equal to T2y, right? So what did we find as T2y? We found, if we go back to the question, that's 122.5 newtons, right? And then now to calculate our mass, remember we can break down the Fg to mass times the gravitational acceleration, which is 122.5. Now we want the mass. Allow me to continue here. So that's m. And then the g is gravitational acceleration, always 9.8, equal to 122.5. Then at this point, what we need to do, divide by 9.8 so that we are left with m, which is the mass. And then our mass is equal to 12.5 kg. So that's a mass m, so that's 12.5 kg. And that's how you were supposed to calculate this question, or solve this question, for a total of 11 marks. So please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And then if you've been watching the videos and haven't subscribed yet, what are you waiting for? Please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Do not leave them in the dark, guys. So with all that being said, ciao. Remember, do not be selfish. We are winning as a team.